Yeah, so everybody can see this GitHub link, right? So what I did is, so previously we had the syllabus page and the project page on a Google Doc. I just moved it here so that everything is at the same place. And once you learn, maybe this week, or hopefully you've already learned last week, once you learn how to clone this particular folder, all the updates in this folder, if you especially git clone it, you can easily pull the updates, and therefore, if there are mistakes or if there are updates, then you can just get the latest version by applying a git pull or basically git fetch operation. Okay, so just to, I guess, reiterate, I have removed the syllabus page, or changed the link to the syllabus page on Blackboard. So it's basically the same content. I just copied the text into this notebook file. As you have seen before, at least last time, a notebook file can have both code as well as text, and so this particular notebook has mostly text. Um, and I've also removed references to lectures specifically, and just call them chapters. That's because we may, spending more time on chapter one, for example, this today, because we only got up to setting up Python, towards the end of last lecture. So we will continue from there. And so we may be covering parts of, we may not be exactly covering, for example, this set of chapter 2 contents this session. Okay, so in that sense, we'll probably be covering maybe a part of chapter 2 today, and a part of chapter 1 that we for today. Okay, so in that sense, I just renamed them to be chapters. And if you go back to this, this link hopefully is available to everyone. If not, let me just paste it here in the chat. Second thing is, the project link is also, it's also updated on Blackboard. It's just a collection of recommendations, or basically guidance towards the project that you would be doing, which is the main deliverable from your point of view for this course. And do spend some time reading about this. And last time some of you were able to introduce yourselves, so hopefully you can connect with each other offline. If not, reach out to me, that if you're not able to reach out to some other people who are looking for teammates, me or Teng Teng, who's the TA, can try to match you guys up. Okay. um, and I guess the third logistical thing is, I just rearranged the previously, if you had seen this repository, there was lecture one, part one, lecture one, part two, lecture one, part three, and so on. I just moved it to a subfolder. So chapter one, for example, has the same thing. Instead of, again, I said, instead of calling it a lecture, I'm just calling it chapter, only because we may be covering only parts of it typically. I mean, depending on our pace. And so it's better to not refer to it as a lecture itself. And we are on lecture number 2, or the session number 2, but we may be covering parts of wherever we have stopped. Okay, in particular, we had stopped at like 04, which was intro and setup to Python last time, and we'll recap some of the previous session, and I'll continue from here. Okay, so this is just the last thing I wanted to point out. Okay, so and similarly, chapter 2's content is here. So any questions at this point about this I guess minor logistics? So there are a couple of ways to access this folder, right? So if you don't want to use the browser to look at the notebooks themselves, um, in browser itself, there are a couple of options. I think last time I might have mentioned that there is, for example, Databricks, which is something that we'll pick up few weeks from now. It's it's again a Jupyter notebook, but it's served by this vendor, Databricks, who is able to set you up with a Spark environment, a Spark cluster. Okay, at least in the community edition, you have a very simple Spark cluster. It's actually just a one machine, or one machine cluster, but that's fine. So it's useful for us to get a sense of Spark, because that's useful for the large scale processing. But you can actually open the Python notebooks here as well. So if you log in, let's say you log in here, it may have some files from last time I had accessed it. But for example, you can create a new file, import, or create a blank notebook, and you can this is just going to be a Jupyter notebook, so you can copy stuff or import stuff from this repository. That was one. It's a little bit, so you don't have to jump onto this one. The second one I said was collab.research. So here again, you can access any Git repo, and in particular our Git repo. So we can go here and type MLOps notebooks, and you should be able to see all the notebooks, and you can just open them. It's not that they're going to be saved on your machine. It's not going to be um, saved on it's not going to be saved on Google Drive as well. I mean, you can just open the notebook, but if you save a copy to your drive, then it will be saved onto your Google Drive. Okay, that's the second way. Third way is Jupyter .org itself has a nice service. I think, yeah, it's called NB Viewer. I think you can see it as a top, um, top link here. So if you click NB Viewer, then it can say, hey, if you want to simply look at Jupyter notebooks or share them, and make it readable, you can just you can provide any URL. So for example, Teja dot, I have a website called teja.org, so I can do teja.org slash notebook.ipython nb ipynby, and I can just post that URL here so that it's easy to see that file. Okay, because otherwise it's just a text file with extra metadata. You will not see, if you just open it using text editor, it will not look good. Okay, I mean, these notebooks ipynbs. Okay, so you can just type, for example, I don't know if this works, but MLOps. Let's try. Yeah, it works. So you can just, for example, I can go to chapter 1, and if I click on recommendation models, which is something that we'll cover today, and you can see, hey, these are the Python commands that you can run, and there's also text above and below it. Okay, so these are several ways to do it in the browser. If you don't want to do it in the browser, that's another option. Just use go to code and download the zip file. That's one quick and easy way. But the issue with this one is you will have to re-download every week. Let's say chapter 3 comes out, then you'll have to re-download it. Another way is to use this link here, and in Mac OS and Linux, it's easy to what is called a clone, or make a scan, or make a copy of this folder on your local machine. By the way, Git is a software to version control code, just like on Google Docs or even Microsoft Word. You have a way to keep revision history. So we'll not get into Git today, but the last way to do something offline, not in the browser, is to get this link and type something like git clone. Okay, and maybe I can show it. Actually, I'll show it today. Any questions about this part? Accessing, the material is very important. So there's so many ways, but the simplest way, is to get it to browser. Or if you don't want to do anything, just go to this URL that I shared on the chat, and just click on any of these notebooks, and you'll be able to see it. Okay. Okay. So we'll continue where we left off last time. And actually, what I wanted to do is also quickly recap what we saw last time, because I think especially folks who are using Windows, there's a little bit of a friction, because you don't have ready access to a terminal where you can run some command line, I guess, commands. So how many of you have tried getting up to setting up Python either locally or on a remote machine? How many of you have not tried? Let's say maybe you can post on chat.
Professor Teja, this is Laura, but I have like the Jupyter notebook from the Anaconda package. Is that fine? Or
yeah. Okay. So that's totally fine. We don't need Jupyter. Yeah, that's totally fine. You can work with that. So the route that we're taking last time, if you recall, the main context last time was, let's set up a standalone. Let's rent a machine on the cloud. We were trying DigitalOcean last time, and today maybe I'll recap with AWS. We rent a machine and be able to run Python code, because the Python code is the one which is going to help us serve the model. Okay, so on that remote machine, we could optionally also install Jupyter if you want to just have Jupyter running all the time and just connect to it all the time, so that you don't have to mess with any Python stuff on your local machine. Okay. So I see some folks have tried, some folks have not tried. So what I'll do is, that's great. Some folks have tried SSH. So that's where SSH is the part where on Windows there are several routes to take. One of the more I guess older route was people used to or still install a terminal utility called putty. Okay, with that you can actually also connect to a remote server. Okay, so let's actually try. I'm not able to demo putty and how to use Windows in this session, but you can send a direct email to Teng Teng, the TA, or myself, and we can debug that initial part of SSHing. Okay, and that's only relevant for this first chapter, which only talks about how to connect to a remote server. A part of it is going to be relevant for accessing AWS as well, but we'll see when that time comes. Okay. Um, so what I'm going to do, what is the best way to access terminal using Windows? So uh, I have a couple of recommendations, but they may not be the best ones objectively. There is a program called Git Bash. Let's search. So yeah, so GitSCM has Git Bash. You can download the Windows version here. That lets you, you can do things like, okay, yeah, you can do some things like this. Okay, so you can actually run terminal commands um, using by having the software, running the software. Okay. That's one painless way. You can have your SSH stuff through this as well. Okay. GitHub desktop version. So GitHub desktop is a way to navigate Git repositories. So this repository, for example, you can clone it. Yeah, you can use GitHub desktop. Yeah, but it's um, it GitHub desktop is not a solution, I think, for Alex's question, which is best way to access a terminal. So there's PowerShell, which can help you access WSL related technologies, which is Windows subsystem for Linux, I think. Um, so I haven't tried Windows WSL related. I have zero. I mean, I have very little idea about WSL. But there are several options on Windows. So one is, um, as I said, just to summarize, one is Git Bash that I just showed you, um, uh, or whatever it's called, Git Bash. The second thing is you can use putty, but that won't give you the terminal, but it'll let you SSH into a remote machine. Okay, as long as you have if let's say if you want to SSH using username password instead of the key files that I was showing last time, then you can just use putty, and you can also log into AWS using putty. So that's the second option. Third option is to use PowerShell. PowerShells with WSL gives you a lot of options. And fourth option is called Sigwin. So these are all like trying to make life easy for Windows to keep the commands the same. Okay, so you can, uh, you know, this kind of gives you like a self-contained, like a Linux-looking terminal, so that you can do same SSH stuff, log into SSH, log into remote machines, and so on. Okay. And finally, the fifth option is to install a virtual machine on your laptop, like a really bare bones one. And once you have a virtual machine using VirtualBox, then it's basically Linux, or basically you can just use the terminal from there. Okay. So there are several questions actually. GitHub Desktop is about looking through Git repositories, not really related to terminals. Using Windows. Yeah, if you have a terminal option in Jupyter. Yeah, sorry, that was another option. So I should have, yeah. So there's one more option, which is if you have terminal access through Jupyter, then certainly use that. Um, I haven't installed Anaconda on Windows. So sorry, I'm just going through a list of like things. Anaconda on Windows may help you access the terminal. So I have to check with somebody who has installed Anaconda. Terminal app in Mac OS, yes, exactly. You can just use terminal app in Mac OS, or if you want a slightly, a different option, it's called item 2 or 3. This is just a name for another terminal instead of the default terminal for Mac OS, you can use something like this. Okay, so these are just Mac OS, you're totally fine. Linux, certainly you're fine. You have the command, the terminal. On Windows, you have like several options, and whichever you feel like the least friction, you should pick. And if you are not unsure about that, email me or the TA, and we can we can help you with that. PUTTY is an option. Yes, Alex. So PUTTY is an option to log into machines. So if you just have a key, username, password, not the SSH stuff, that SSH key pair stuff that I was showing, public key and private key stuff last time. If you just want to keep username password based logging into remote machines, then PUTTY is great. Okay, you just have to plug in the IP address, put in your username, put in your password, and create a secure connection. It's just that enabling username password is not recommended for servers, because hackers or people who have, I guess, ill intentions can just brute force, try all sorts of password combinations and maybe guess your password and get into your machine. Okay, that's the only, I guess, downside on that. But I would suggest I mean, especially Windows folks, I, as I said earlier, I don't know much about WSL, but if you are, if you are comfortable with exploring WSL, WSL should bring in a lot of Linux capabilities into, through PowerShell. And so you may be in a better shape, which since I don't have a Windows machine with me, I can't comment much there. But I would suggest trying to stick with our narrative. So for example, last time you saw that I picked Ubuntu or maybe Debian. That's because even the command line commands may have slight variations the moment you switch to a different Linux distribution. So for us, there are too many options, but we just want to get a sense of deploying machine learning models. So we are making some opinionated choices, which are popular choices. So we are sticking with Ubuntu style command line, command line commands, for example. Okay. So let's actually try setting up a machine. So I think let me try AWS if I'm logged in. Say sign into console. So you just need to create an account with AWS if you haven't. So I have previously logged in, and then you can see, Teja at something is my username here. So you'll basically be seeing this once you create an AWS account. Okay, and I'm gonna quickly recap what we did last time. So let's launch a virtual machine. So instead of DigitalOcean, I think last time, which we still have, it's still running, but let's pause it. Let's not worry about that one. So you can see there are several options here. Um, um, so let's say quick start. So we can pick Amazon Linux. We can pick any of these other things. Um, I thought there would be free tire eligible or something. Let's see, EC2, nothing is running, and oh, okay, dashboards have changed from last semester. Okay, instances, and let's say we want to create a new instance. Okay, this is the default. Okay, let's pick. Actually, for us, it really doesn't matter. So let me just select Amazon. Okay, there is an option on the left side called free tire only. I didn't see that. Okay, so let's select Amazon Linux. I think it's our Ubuntu. I think, okay, let's pick Ubuntu. Okay, let's pick Ubuntu. And this is what I was mentioning last time, that hey, this is free tire eligible, especially if you are in the first 12 months of your, I mean, if you just created an account, certainly you can keep this machine running throughout. Okay, yeah, and the 750 hours is basically about a month, so you should be in free tire. Okay, so there are some options, how many, so this is where I think it is not a physical machine, it's a virtual CPU. So it's actually a VM virtual machine running on their side, but from your perspective, it's just a computer. Memory is 1 gig memory, and storage is kind of perishable. If you turn off the machine, the machine is completely gone, your data is gone, things like that. Anyway, so let's we'll talk about some of these options later. Let's is there anything else to choose? I think it's just review and launch. Your security group is open to the world. Okay, I didn't change any security group. So what are they trying to say? They're trying to say that, hey, we can launch this machine. You have access via SSH through port 22. I think last time I mentioned this analogy of ship port. So there are several ports that can be open. So this is saying port 22 is open, but it's open to everybody. Okay, this the source means if it's if you see 0,0,0,0,0/0, it just means that, hey, anybody from anywhere in the world can access this port and try to log in as long as they have credentials, maybe a username password, or in this case you will I think Amazon, you need a key file. I think they automatically uh, make you generate or something, or in what we saw last time, which was to have this SSH key pair. Okay, um, trying to juggle a few things here. So let's see. Edit storage, edit stacks, edit instance. This is all fine. Um, yeah, let's launch it. Okay, now, so this is where I think Amazon's workflow is a little bit different from what we saw in the DigitalOcean's case, and people can review back by looking at that recording. So you can choose a key pair. So this is they have a GUI way to say, hey, let's create a key pair. You don't have to generate a key pair on your local machine, and this is where you don't need a terminal. I think somebody asked, can we just use PUTTY and not worry about anything? You just need, so if you do this, let's say you set up a remote machine on Amazon, you really don't need anything on the Windows side in terms of SSH keygen and all that stuff. uh, these guys, Amazon will create a key pair. You just need to somehow supply that appropriate, there's a file that's going to be generated, and you just need to supply that to PUTTY appropriately. Okay, and there are a lot of, you'll have to do, I'm not going to go down that tangent now, but let me say, let's create a new pair. This let's call it Amazon. Let's say, what do we want to do today is a Flask server. So let's see if we can, let's call it Python. um, yeah, so let's say this is a key pair name. I'll download it. Okay, so the key file name is called PEM file, and this is just some file format. Let's not be concerned with what it actually is, but this is a way, this is a key, this is something you should be guarding with secret. You should not publicly give it to everybody. So this is the key which you can use to SSH into the machine that we are trying to create now. Okay, so let's save it. Okay, let's save it. Yeah, let's save it here. And then let's launch. Yeah, as it says here, store it in a secure and accessible location. Let's launch instances. Okay, so we are launching the instance. And there's some information. I think we can just go to view instances. And you can see, the instance state is pending. Eventually, it'll be, running state. Okay, and in the meantime, I think we can, if you choose it and go below, you'll see some information about how to access this machine. In fact, it's already running now, and this is the public IP address. So this is what I can use to access into this machine. Okay, I can copy that. And am I running Jupyter? Let's see. Okay, so what I'm going to do is, so I opened too many things. Let me close a few of these things. Item not needed, segment not needed, git not needed, start page not needed, Jupyter. I mean, we're going to just use git. What is this? No. Not needed, not needed. Okay, so what I will do is start a local Jupyter instance on mine, so that everything, so I can show you, yeah, I can show you some of the steps I'm going to take. So let me do that first. Okay, so what I meant earlier was I'm just going to create a Jupyter notebook, Jupyter server locally, just so that everything is in the browser. I don't have to switch between different things. So anyway, so don't worry about these files here. So what we're going to do is, actually, let me close that and open it in a clean folder. Okay, so it's a clean folder. It's just a subfolder that I just created. Um, so first thing, so there's some subfolder. So this is my teaching folder anyway. I just created a subfolder. So I'm going to do git clone of that repo. Okay, so I'm just doing everything from scratch. So let me clone it. Okay, this should get you the whole directory. And once I get that directory, I can just click on it, and I can locally also access these notebooks. That's what I meant earlier. So now let me create a terminal here, and I copied so we just created an instance. So that's as simple as that. Just click, 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 and as long as you have some sense of this, what is going to be security groups just means which port should be open for the external world. Okay, and you can keep it as tight as possible so as to not get basically hacked. So let me copy this, and SSH. And this is where that file that I created, so that we downloaded earlier, um, in the download folder becomes important. Let me um, copy into this folder here. Yeah, you can see that I just copy pasted that folder. So I think I probably have to also change the permissions. I don't know, but it's basically just so that this file is so it should be secure by default. Okay, in Linux, there's this notion of, hey, who all can read this file? Not everybody can read this file except me, the user with username Teja, can only use this file, read this file. Okay, that's just change the access permissions to this file. Okay. Um, Now what I can do is ssh -i and this file. Okay, so I can just give this name, and then ec2 user, I think. Actually, I'm guessing this at this point. Okay, and then I can, again, I'll have to copy the um, okay, so it'll say, hey, you're connecting to a new machine on our end. It's just saying, okay, let's connect. And it's not the key. Okay, wow. Let's see. Is that not the address? What is the username? Okay, let me just see the security groups. Port 22 is allowed. Okay. Okay, let's call it. Let's change permissions to a slightly different setting. Oh, this is not the key. Actually, maybe the username is not correct. I actually don't. Let's see. I think it's EC2 hyphen. Okay, let's see. We chose Ubuntu. Oh, it's okay. The username is Ubuntu. I think I picked the wrong username. Okay, So now we've logged in, as you can see. So this is literally, this is where I guess big friction is to somehow quickly rent a machine. And we rented this machine, and especially if you've created just an account recently, then don't worry about any charges. This is a free tier instance. You can run it through months, for the next 12 months, and it'll keep it on, basically the machine, and you'll not get charged. So we've logged in. The SSH part is actually already taken care of, so we don't have to do some of the things that we saw last time for this machine. So let me quickly recap. So what did we see? Um, yeah, so SSH passwordless, we have actually already done that, in the sense that using the PEM file, we didn't have to do anything. So actually, there's a question. I guess you have to connect you have to connect it first, the instance. Yeah, I just created the instance. I just copied the public IP. Just have to ensure that SSH is allowed, in the sense this port 22, anybody can access it. So it's just, this line is just saying, hey, this port, some protocol, actually this is not very critical. Everybody can access it. Okay. And once you have this, and remember, we downloaded a PEM file. Once you do that, you just have to know, you just need to have that PEM file somewhere in some folder, and this file can be given to uh, putty, but I'm not sure if it's a PEM file or there's a slight variation of this file that I think we'll have to. I don't have a ready reference for that, whether this is exactly the same file, or you just need to slightly transform it and then pass it on to putty, I think. So I need to double check that. Um, but basically, once you have this file, you can just do SSH. If as long as you have access to a terminal, you can just do SSH, that file name, um, and Ubuntu is the default username, and whatever is the IP address. Okay. Um, so we have logged in, and actually, uh, we also don't have to do a few things that we saw last time. So let me actually get to that. So this was the basics file, and then the basics file, and then we had to create. I mean, so in DigitalOcean, we were actually logging in as root. So we had to create a separate user account. Here, actually, as you can see, the user is Ubuntu already. It's not the it's already in the sudo list. Okay, so you can see that it says so you can use sudo, which means that this particular user, which they created by default the moment when we created the instance, it's already in the sudo group. So I can use sudo, let's say apt. So this is just a command to update to get the updated list of software locations, like software versions, sorry. So apt-get update, for example, hits a bunch of, um, so it hits a bunch of servers to just get updated versions of software. It doesn't download, the software themselves. It just gets, hey, here's a new version potentially available. It'll make a list of it locally, okay, for example. And you can see, you can do extra stuff. Hey, these many things can be upgraded and so on. So anyway, I'm just saying that this user Ubuntu is already kind of a super user administrator account. Okay, although it won't say root here. Okay, and that's what we did last time. There was this, logging in as a root as a default username is not a good idea, and not allowing anybody to have root access is a good idea. Okay. Um, so anyway, we don't have to do the step on Amazon. SSH, as I said, this part is all kind of done using the PEM file. So we don't have to do anything on the server side on this remote machine, which on AWS. Um, Firewall, as you saw, there is already a security group. Where is this? There's a security group which only says, hey, only 22 is allowed, nothing else is allowed. So we don't even firewall is redundant in some sense. If you want to open a few, like if you want to allow, let's say, generally websites are served on the port 80 or 8080. And so if you want to expose that port to the internet, a firewalling is not enough. Basically, you have to say, hey, in security groups, add one extra thing, which is port 80 should be allowed by anybody else. Okay, so only if I do that, then it'll let like if I run a web server, then it'll hit that location. Okay. Um, any questions at this point? So we have already logged in, and we have kind of, some of the steps were kind of, we had to skip because they were already done. So let's go back. And then now let's set up. So folks who don't want to set up and mess with Python locally, you can just install Jupyter remotely. And every time you want to access that Jupyter or the remote machine, you can just use the browser and have an interface like this, right? So we're going to do that. And for that, we just have to run these commands. It just installs a version of um, Python and the Python ecosystem through this distribution by Continuum, the company. The distribution is called Anaconda. So let's do that. So get the file, and so chmod just means change the mode. Make so plus x means make it executable. So you might see sometimes these commands, but I would say at this point just memorize them as we don't have to worry too much about them. So we made it executable, and then dot slash uh, and the file name executes the file. Okay, so we're just gonna dot slash enter and says, hey, where review the license. Okay, let's do that. More. You can just scroll down. Okay, if you do down arrow, it'll go through all the agreements, and then you agree. Let's say yes. You don't have to do you install Python, by the way, in this way. I'm just showing you one option. Later on, I think in a couple of sessions, we'll look at some other way to install Python. Okay. So Python, by the way, is also available by default in Mac OS and Ubuntu already. Some Python version is already going to be there in the system. I'm not sure on Windows if it's already available by default. Maybe not. Um, but we don't want to use system installation of Python. We'll just use something which is locally contained. So it's just in a one folder, so that later on, if you decide, hey, I don't want all this mess of Anaconda, you can just delete that folder and that's it. So you don't have to. There's nowhere else that this installation touches. Okay. In particular, it's saying that we'll touch Ubuntu. We'll only create everything under my home folder. Home slash my username is Ubuntu here by default. It's going to create stuff under this folder called Miniconda 3. Okay, I can just press enter here. And now I think it'll probably do a lot of downloads and installation. Um, okay, so it did something, which is just install the smallest set of packages. I think you can install the full version as well. There is a slightly different version which is not shown in this notes. Instead of doing slash miniconda, you can do something different. Okay, but that's all optional. Let's not deviate with all the tangents. So uh, what is it saying? Do you wish to initialize miniconda? Okay, let's say yes. Okay, so for changes to take effect, you need to close and reopen the current shell, which for us just means let's exit and then SSH back in. So you can see now there's an extra string which was not there before. Okay, so it's base. Okay, so here you can see first word is called base. So that just indicates that we are in the base environment, enabled by a command called conda. Okay, so conda is a environment manager. Okay, and what we're going to do is, and this is something that you will see in many professional settings, that you would want to have a self-contained um, environment. An environment just means all the situation around which your script is going to run. Situation as in the basically, for example, what's the versions of software that your script may depend on. When I say script, you think of the model serving or the model training script, or even data processing script that we may work on. So everything related to that script, for example, dependencies or things like that, can be managed using an environment manager. Okay, and Conda is an environment manager. There are many alternative environment managers. Later on in the course, we'll look at another one which is specific to Python, but Conda is not specific to Python. Okay, although here we are just going to manage Python with Conda right now. So the big idea is you can have multiple environments. So let's say environment for, let's say you're a consultant, okay, and you're consulting with company A, company B, and company C. Let's say company A works in the embedded or IoT space and works with Python 2.7. Let's say company B works on, let's say, Python 3.6, and they're like a Fortune 500. They can't really keep updated with the latest versions of Python. Maybe company C has the latest version of Python, like 3.8 or 3.9 or something. Now, how do you manage all this if you're a consultant, right? You may have one work machine and maybe you log into their systems and all that. So Conda or environment managers help you like switch between environments where you seamlessly can jump between, the whole software looks as if it's on Python 2.7, for example, for the first firm, or for example, the whole software looks as if it's Python 3.6, and everything else is nicely installed, same versions, or you can jump to the third one. Okay, so that's what. So you can switch between environments, like different rooms on the same machine. Okay, generally, for example, many of the typical softwares that you install, like let's say Firefox, it's not like you can install Firefox or Chrome version whatever 60 and then also install Firefox and Chrome versions 80. Okay, generally your OS will not let you install two different versions. But these environment managers basically ensure that you can run the Python, like you can have Python, the underlying software being, let's say, 2.7 version or let's say 3.8 version without any issue. Okay, and you can switch between environments. I hope that was somewhat clear. So as you can see in the notes, so the second step you generally do, and this is just a one-time step for us in this course, we'll just create a data sci dev, or I guess data sci n environment, or dev environment, doesn't matter, some name, you can give some name, and it'll create that environment. Okay, so whatever we install is only going to be specific to that environment. So we just have to and you can create many environments. So base is one of the default environments that you saw here. This base is a default environment. So let's actually just run this command. um, oops, um, okay, it's saying, hey, all these will be installed. So some minimal number of things will be installed. And let me press enter for now, and I'll show you what the difference is. So you can see I'm still on the base environment, but I can do conda, I think end list maybe. Yeah. So you can see, so it just lists, where is this? Yeah, conda end list, where I ran here. By the way, everybody can see my screen fine, right? Has anybody any issue with seeing my screen? Okay, so you can see there are two environments, base environment, and there's a data sci environment. Okay, so you can switch between one or the other, and this is what I said. So let's say you're doing your I'm sure you guys are taking multiple courses, and so maybe for each course you have a different project and different requirements, right? Maybe if you're taking deep learning course, you'll need to have let's say PyTorch. For this course, maybe you don't need PyTorch dependency, so you can create two different environments where PyTorch and all the complications, let's say you need to use GPU and GPU related software, all the complications can be just in that environment. And maybe in a different course, you can just have a different course specific environment. Okay. And so you don't have to mix, you don't have to worry about version issues. For example, maybe for course one, you don't want to execute a script and it needs a specific version of some underlying software where underlying, let's say, module or package in particular in Python. Whereas the course, this other course may need a different package. Okay, and this can happen. It's not that rare. Okay, in fact, for this course, packages have changed since the last semester I taught this, and so I had to go back and revisit and update or remove some code because of those package issues. Okay. If I had maintained an environment from last time and I could reuse that, then it would have been great, but I didn't do that. So that's the idea. So once we create an environment, we can do conda activate data sci n, and what it'll do is to let you know that you have now switched environment. It'll change the base here. You can, so the first word to data sci, so whatever is the environment name. Okay, so you can see it's now data sci environment. So this is a good practice. So to be in certain environment, and then in this environment we can install Jupyter. Okay, so like conda install Jupyter. Uh, let's enter. Wow, so many things to be installed. So let's install this, and it'll install only in this environment. Just as a side note, we are running this on that remote machine that we rented. If you terminate that instance, you lose all this activity. Okay, everything that you've done. So if you have some tangible things that you want to take away, you should try to download it. Okay. and there's some ways to download it. For example, secure copy is a way to download it, and I'm not sure. There are some apps. For example, there's an app called Fetch, which is available through the university store um, for Mac, which can do SSH into remote machine, and you can just copy files if you want a GUI experience. Um, yeah, so now we install Jupyter. So now let's say, I don't know if I, yeah. So I deactivated, and now I'm back in the base environment. Now if I say, let's say, if I type Jupyter, it says, hey, Jupyter is not installed. Okay, you can install Jupyter, in different ways. Let's not worry about these ways for now. Now let me go back to Conda activate data side dev, and if I type Jupyter here, it will say, hey, Jupyter is available. So you can see, hey, use it in certain ways. Okay, and now what we're going to do is now continue where we left off. We have the environment, we activated it already. Now we install Jupyter. We didn't install pytorch yet. Okay, let's actually install pytorch because we'll need it for next time in a few minutes. Yeah. Um, yeah, so pytorch has this weird, so where did I get this, long string? Instead of just calling pytorch, I just went to pytorch's website, and they said, they recommended, hey, this is how you should install it, on Conda. I think, yeah. See, if you say, I want a stable version, Linux, Conda. So these are different ways to do it. Conda, Python, I have no, let's say I don't have any GPU, then you need to install it this way. Actually, now it has changed to include torch vision and torch audio, but we don't, I just, yeah, I don't think it matters if you need torch audio or not. Actually, let's see, CPU only. Yeah, that's fine. Okay, so let's install PyTorch just to show you how to install other packages. There's also another way to install packages in Python. So this is all happening on the remote machine. On the remote machine, we have to use a terminal, by the way, right? So that's why we are kind of stuck with the terminal for now. But what we'll do in the next couple of minutes is start Jupyter. Okay, and this is where we kind of left off last time. We stopped at installing this Conda package, so Conda distribution, Python distribution. Sorry, Anaconda based Python distribution, and so what we're moving forward from that. How to install Torch Audio after you did this part? You can just do the same. You can go back here and say Conda install Torch Audio. If it doesn't work, I would say just rerun this command. It's basically the minus C is basically saying I think it's basically saying where to get access to this PyTorch, I guess, package. So I need to look it up. But if you want Torch, I mean, you can run the whole thing. I mean, I just didn't choose to do it. Wow, examining PyTorch. Okay, let it run. In the meantime, so what you're going to do is start Jupyter, and I'll just create a simple. We actually don't need a. Okay, let's create a password because otherwise it'll do some token-based authentication. So let's actually just follow this instructions here. Let's see what's the situation. Okay, so it says, oh wow, package PyTorch conflict. Oh wow, let me just check which version of Python it is. Sorry, minus. Oh, for Python 3.9, we should do what? Is this it? Minus C is equal to conda forge. Okay, so let's change this to this. So this is exactly what I was saying, that even from month to month, things may change. And so pinning your dependencies, I think that's what they call in software engineering, is kind of important. What does it say? Oh, there's 2 times PyTorch for installation. And I think Yeah, actually, I didn't realize that they have made it even more complicated installing PyTorch. Um, Incompatibility previously. Um, oh, conflicts of PyTorch and Torch Vision. What did it say? It didn't install. Failed with initial retried. Wow. Okay. Uh, I don't think definitely PyTorch is not installed. Um, okay. Sorry about the font colors there. Interesting. Okay, so this is where I guess it's really beneficial to now really utilize what we learned in the previous 2 minutes, which is now we're going to do conda, deactivate, um, and just switch over to Python, older version of Python. Okay, so let's go back here, not activate, create an environment which Python is equal to 3.8.6. I don't know if that's a, and also just install Jupyter right now. Okay, PyTorch will leave. Oh, no, not data site there. So let's call it data site 38 or 3.8. Which Python? Which Python? 0.8.7. Let's say 3.8. Sorry, I'm just trying to install an older version of Python and seeing if PyTorch installs, because that is needed for me to illustrate a simple recommendation model in a few minutes. Data site 38. And now let's run that conda. I hope it works. Any questions in the meantime? Yeah, I think it's found some packages and it's installing it. So this is where environments help. There is that other environment. We can delete that environment because it's Python 3.9.1. There are some changes actually. So every time version bumps occur, there are some new language features. So those who are curious can look into what new features got added in 3.9 compared to 3.8. But um, yeah, next we'll run. So next, what I'm trying to do is it's a small trick to get rid of this token. So we'll just make it a password-based access to. So we'll connect to this Jupyter. So what we'll do is three things. Step one, we'll run a Jupyter server on this remote machine on AWS. Step two, we'll open our browser and get to that Jupyter instance. And step three, we to access Jupyter, we will also create a password-based access. Okay. So let me just do that. So what this generate notebook does, it's just a generate config does is just creates a temporary, like a py file in the user directory called Jupyter. Okay. So in a folder, it just creates a py file. It just holds some configuration options. Okay. We are not very interested in those options. What we want is just create a simple password, maybe something like IDS 594. Yes, 594. Okay, so we created a password. And now what we'll do is um, we want to run this Jupyter server. So it's a machine which is going to continue running this Jupyter server forever. Okay, we want to just run it till I terminate this machine. So for that, what I'll do is I'll do screen, which is a way to let a program run even if I close this terminal. So what I'm seeing in this tab, if I close this tab, I lose connection. If I start Jupyter directly and if I close this tab, the Jupyter will stop running. Okay, may stop running. So one way to do that, one way to get around it is to run Jupyter in some sort of a hey, keep it running even if I log out. Like I can do exit and log out from this session, right? Like I can just exit here. So even if I exit, connection to this remote machine has been closed, Jupyter should still run. And so to do that, we're going to do it the following way. So again, I have to activate this Jupyter. Sorry, first let me do the other thing. So to keep it running, there are many options. One of the options that as again, at every decision step, there's going to be many options. One of the options is using screen. Okay, if you type screen, it'll look like nothing has changed. So it says, okay, it looks like nothing has changed. But what has happened is it has opened a terminal within a terminal. Okay, and then here I can again, okay, I'll have to do conda activate data sci 38, and then do Jupyter. I think there's a nice command here. So I could have done extra things here, but it really doesn't matter. Um, So this command is saying, hey, run Jupyter Notebook. And this is how you typically run Jupyter Notebook in addition to directly using Anaconda. If you use Anaconda, there's a button, it says, hey, start Jupyter server. If you don't do that, then this is the way. If you have access to terminal and Jupyter is installed, like conda install Jupyter, then this is how you start Jupyter server, okay, Jupyter Notebook. Okay, minus minus no browser just means don't start opening a browser. Like typically, if you type Jupyter Notebook in a command in a terminal in a local machine, it'll say, hey, let's open Chrome or let's open Firefox or one of these or Safari, and let me start the see the Jupyter interface. Let's not do that at this point. Port. Uh, 8888. Okay, let's start it. Okay, we started this. Now, what we can do is uh, we need to press a magic, I guess, command. So magic key press, which is called Control A D. Okay, Control A D. That you can see at the first line, it says you detached. Sorry, you detached from that from something. Okay, that just means you detached from this another terminal that I had opened. If you want to reattach it, reopen that terminal, you can just do screen minus R. Okay, so if you do that, you can see that, hey, now in this terminal I actually ran Jupyter Notebook, and again if I do Control A D, I'm out of that, and now I'm back to my original case, and here I can exit this machine. Okay. Unfortunately, that Jupyter which is running cannot still be accessed because we need to see if we can edit this security group. Let's click on this security. Okay, there's one group attached to this. So let's click on that group here. So okay, so what I'm doing now may seem a little bit ad hoc here, but what I'm trying to do is every machine or every instance, a resource in AWS, typically, let's say this compute resource that we used, a machine, it's related to, you can attach what is called a security group. It's a policy. Okay, this in particular one security group. Okay, that in particular this group has only this access. Okay, you can only access to assets. What I'm going to do is change this guy's uh, policy to also include access to that port 8888. Okay, that's all. So nothing to do on the machine itself, virtual machine itself, just something on the AWS. So AWS interface. Again, how did I get here? I just, if on the instances pane, you'll see the instance, click on the instance ID, and just go down and click on security and click on the group. Okay, we're just gonna modify the group. Okay, edit inbound rules. So there we're gonna say, hey, add some rule. Let's say custom TCP 8888. You can come from anywhere for now. Actually, wait a second. I think, oh wow, actually we don't need this. I'm so sorry. Because so I was going to do SSH tunneling later. That's the next step. So we don't need to change the security group. So let me step back a couple of minutes, just one step. Let me not add any rule. Although since we are here, let me add the flask. So let me just make port 80 world accessible. 80 is just a port for your web server. And eventually in a few minutes, we're going to run a web server with our model to predict. So let's keep port 80 anyway. Okay, so this is just a tangent. You don't need to change anything here for at least the Jupyter part. Okay, so let me just save this, port 80, and yeah, save these rules. Um, yeah, so you can see in the list, it's port 80 is available and port 22 is available. So people can only hit this machine or reach this machine through these two ports. Okay, through these, sorry, through these two ports. So let me come back. We have run Jupyter on the um, a remote machine. So what we're going to do on a local machine is a specific command. Okay, and this command, again, for people on Mac or Linux, it's just, it's a command that you can run easily. On Windows, putty is not sufficient for this, for tunneling. What you need is, again, those options that I had listed earlier, like git bash, or Cygwin, or Windows subsystem for Linux, or something like that. Okay, or you can run a VM through which you'll have therefore Linux, and you can run all these commands. Okay, so let me copy this. Um, since I exited, oh, I didn't exit here. Let me exit. So now I'm back to my local machine. So as you can see, on my local machine, I had that PEM file and the folder that I git cloned earlier, right? So what I can do here is uh, copy and paste that. Actually, in the meantime, let me know what the username. Okay, let me. Oh, why do I have two different ones? Okay, doesn't matter. So let me do it here. So I just copy pasted that command here. Of course, I did not give the right username or IP address, so you cannot do anything here. So here I just wanted to change that username and IP address to the machine that I have. So which is this Ubuntu at some IP address. An IP address is just a public address, just like physical address that everybody has. Um, let's come back here. Okay, so now if you press enter, nothing's going to happen. Um, hopefully, no error. No, okay, actually, I need to give the key, which I forgot. Um, -I. Let's see. Yeah, ideally, it should not say anything, and that means you've succeeded. And then what you can do is go to any tab, and so what is this command? What is this command doing? Okay, where is that? This command is saying, hey, there's some local server running on the remote machine. So let's look at the third and fourth, thing in this 4-word string here, like localhost something else. So last two words are saying something is running on the machine, remote machine. Okay, in this part, in our case, it's the in this IP address machine that we created. Okay, there is some process running. Okay, in our case, actually, it's a Jupyter server. What we're trying to say is, hey, use SSH and access, whatever, the server is running, and if you are locally on that remote machine, you could just open browser and say localhost colon 8888 to access Jupyter server. But since you're not locally physically on that remote machine, use SSH to make this query on the local browser, hit that 8888 port, and therefore access that thing which is running on the 888 port on the remote machine. Okay. Or in other words, informally, this command is just letting me access Jupyter server, which is on the remote machine, through the SSH protocol. Okay, so I'm gonna go to the remote machine, use port 22, get into it, and then say, hey, let me go to port 888, where Jupyter server is running. Okay, and that's what this command is. This is called SSH tunneling. Okay, or this next command. And with that, what we can do is now we can locally access that machine. Okay, so instead of 8888, let me say 8889, which is what the command said. Locally, I should open 8889. Okay, so if I do this, hopefully it should open this. You should see this interface. And if you recall, we had just typed, I think IDS 594 as the password, and now you can see we are at, let's say, we are at the remote machine. Okay, and how do I know that? Let's open, let's say, terminal or a notebook. Actually, let's open a notebook. Okay, Okay, this is running on Amazon. So dollar. Um, how do we know the? Okay. Um, Sorry, I didn't want to. So I just wanted to show something so that you know that it's a low. It's the remote machine. Okay, this is the machine that's um, it's an Ubuntu thing that's running on there. Okay, or for example, if you want to get the IP address, um, so just to know that it's a remote machine. Um, this is not present. So okay, this is also not correct. Okay, what's the best way to show the IP address? Uh, hmm. Well, is anybody not sure that this is a remote machine? I don't want to show arbitrary commands to show that this is like, for example, if I do $ls, you can see that we had just downloaded that, and we just created this untitled. So let's say I change this to, hey, first notebook. And if I do again ls, you'll see that it's the first notebook. This is all running on the remote machine. And if you really want to check that, I can go back to this. Um, um, I can SSH into that machine. I can press enter. I think I can press ls, and you can see it's the first notebook. Okay. So anyway, so now we have access to this thing, and we don't even have to log into that machine, through terminals or anything like that. So once Jupyter Notebook is running, you're done with the remote machine. You don't have to touch it anymore too much. Okay. Every time you want to access the remote machine, you can just go to localhost, let's say 8889. If it says not found, just rerun that command that we showed. This SSH, um, something like this. I mean, it will be different when you launch your machine. IP address will be different, but everything else should remain the same. I mean, maybe the PEM file key name may be different, but everything else should remain the same. Okay, so good. So now we are here. Um, yeah. Now what I want to spend time on, since this is not a machine learning modeling class, I'll try not to. I'll try to give you a sense of how this model looks like, but they'll not get into too much details. I mean, certainly ask questions if there are some first order questions about this model. So what I want to do next is to just give a sense of the model that we want to deploy, and actually deploy it using a Python package, in particular a web framework called Flask. Okay, so just like there are web frameworks in many other languages, and web frameworks for both backend and front end and stuff like that, there's some package in Python which lets us nicely do nicely deploy machine learning models. Okay, especially if they're written in Python. Um, so for that, the prototypical or the canonical running machine learning model for this course is going to be recommendation systems. So is everybody aware of recommendation systems? Uh, so I don't know. So have people worked on recommendation system as part of their previous course, like for example, a assignment or something? Okay. So I see some folks saying yes, some folks saying no. Yeah. So yeah, exactly. So somebody asked, so Anupriya saying, is it like Netflix recommendation of movies? Yes, exactly. So some of you maybe in your 572 class might have seen this. So uh, so recommendation models are exactly what the name means. They are machine learning models which, when a user comes, typically they'll have a profile of whatever they did before. For example, some movies that they watched, and we just have to, based on their profile, and maybe they, based on some information like basically what they watched and maybe extra information about them, maybe their age, gender, and stuff like that, make a recommendation on, oh, hey, look at these, this next movie, or maybe give a recommendation list, like here are the 10 movies which are most likely that you may enjoy or something. Okay. This recommendation modeling, there are a lot of nuances about modeling, and there are so many models themselves out there, that we will not be covering about those details, but we'll see a couple of simple models. Okay, and in particular, I'm just going to show two different packages. two different Python packages to just implement such a recommendation model on a much smaller movie data set. Okay, much smaller movie recommendation data set that's available online. It's very similar to Netflix data set from the Netflix challenge 10 or 12 years ago, but it'll serve our purpose. Okay, and in fact, you'll see already some scaling aspects here. So we look at two models. In fact, yeah, I think both models actually, yeah, both models have their own strengths and weaknesses. But I just wanted to show you just two variations so that it's the same data, and at the end of the day, the model has to predict the same thing, which is recommend for a given user, hey, tell what's the new movies. But we'll just see that the model underlying models are slightly different. In fact, I've tried to keep even the models the same. So let's go through that first. Um, okay, so for this, we'll use one extra package. So similar, we have been installing packages in the past few minutes. So you can see a bunch of packages that are needed for this. So what we're going to do is first train a model. So the process right now in terms of my explanation is going to be follows. I'm going to first describe the training procedure and therefore the model itself. Not so much about the training procedure, but what is the model? And the second part would be how do I use that model to infer new movies, for a new user. Okay, so whenever you do this prediction on a test instance, it's called inference. Okay, so it's just training, inference, and inference is that second part that you do whenever you're being given a test instance. Okay, so I'll show you I'll discuss first the model and training first, and then talk about inference. So for training this model, training a recommendation model, there are several ingredients. And first ingredient is, I mean, so I'm already like going several levels down and assuming a lot of things. So we're going to be working with movie recommendations. In particular, we're going to be looking at a data set provided by Movie Lens, data set provided by a organization called Group Lens, I think. It's called the Movie Lens data set. And so we're going to pick that up, and that data set, and you'll see how the data set looks like in a minute. One easy way to access it is through this library. Okay, so the library is called Surprise. um, you can install it by saying scikit surprise, and we'll actually have to install it on the remote machine soon. Actually, we can do that right now. First notebook, let's actually drop this and paste it here. So by the way, if you do an exclamation mark, you can actually typically run many of the command line arguments. So now we don't even need to worry about terminals on the server side and all that. So if you just run this command, you just press shift and enter, and it'll install, it'll at least try to install um, this surprise package in our environment, data sci-38, right? Um, okay, so what is it saying? Oh, I think I should have pressed -y or something. It's just asking. Let's see if it works. Otherwise, let's open a terminal. Um, if it has to be interactive, then so -y generally says, hey, say yes to everything.
Professor,
Yeah,
this is Anupriya.
yeah,
I have a quick question. If I want to follow this line of the code that you're typing on Google Collaborate just to imitate your steps and
yeah,
see what's happening
yeah,
by myself, do I
yeah.
have to write this code or do I have to just write the Python code to install the scikit surprise?
Yeah. You just have to. No, this is exactly what we're doing, right? We are trying to install Scikit Surprise. Yeah, you just need to call this. But instead of calling Conda, you'll just have to do pip install it maybe. Actually, even here I can do pip install Scikit.
Because I'm trying to follow your steps on Google Collaborate.
Yeah, yeah.
And okay,
So I
yeah.
don't know. I don't know if it's actually getting installed. um, Good point. So actually, hmm, what is happening to this? So let me create a terminal and do that properly. So this terminal, by the way, is going to be in that remote machine, and I think by default it's going to base for some reason. It should actually be going to activate say 38, I think. So here we want to install that. So let's see. I think let's stop this. And oh, okay, maybe minus y was the issue. Um, oh yeah, minus y, let it install. So it says the following projects we updated, so proceeded and all that, and then it downloaded. Uh, and I don't know if it installed. Okay, it must have installed because we can do import surprise. Yeah, it's installed. Yeah, so you can certainly follow through. You just have to install this. Okay, either using pip directly pip install this name, or you can use conda if you want. Okay, so now we've installed it. Now where was I? So we also need to install a few other additional things. So pytorch, thankfully we installed. We also need to install scikit-learn and numpy. Um, and there's just one, few dependencies. The way this code is written, it does depend on these things. So we need this. So of course you can certainly check is numpy installed. Probably not, because we did not. Oh, it is installed. Okay. So but I'm okay. Import sklearn will not be there. So yeah, it's similar to installing packages. Exactly, it's just installing packages. Yeah, these packages will continue to stay. Yeah, it's just basically install.packages equivalent here. We're just doing it. I mean, this. So the package manager, you can either use conda as a package manager, so it doubles down as both a package manager as well as the environment manager, or you can use the Python's native package manager called pip. Okay, pip. So these are just like I guess in R or R Studio, you directly have the way to manage packages by just calling install.packages or package name. Here you have to use the command line to install the things. Okay, just remind. So yeah, let's install this. I don't know, maybe minus y again. Yeah. Okay, so it's installing a lot of things. Okay, now scikit is also available. Yeah, now we can, if we import all this, it'll be pretty smooth. So actually I don't even have to copy paste here. In fact, I could have cloned that whole repository, for example. um, should I do that? um, yeah, for example, I could have cloned this ML notebooks repository on the remote machine, and so I could just open the notebook. Actually, let me do that. So let's do what is the directory I'm in? Root directory. So I can do git. I don't know if git is actually available. Oh, it is available. Okay, get clone and go back to our repository. Copy this and oops. Sorry, I'm just making a clone of this on that machine. Um, so that the whole notebook is available, so we can just run, instead of doing copy pasting here. So okay, so it got installed, as you can see. So sorry, we downloaded that the repository of our notebooks. So what we can do is again go back to homepage, and you can see here, I haven't refreshed. Oh, actually, it got refreshed. So MLOps notebooks is here. So let's click on that, and let's go to chapter 1. Let's go to recommendation models, and it's the same. It's just a copy, and let's run this, and it ran. um, so okay, so we are now running a version of our class notebooks on the remote machine. And it's why is it the remote machine? It's again 8889. If you want, we can turn. I currently have a local Jupyter instance also running, but I can turn it off so that there's no confusion with anything. So okay, let's talk about this model. So the first model is a PyTorch based model. So how many of you have never worked with PyTorch before? I expect a lot of you haven't, but um, okay. So Son has not worked on. Okay, like okay, not majority of you have not worked on it. I know a couple who have looked at PyTorch before, so that's great. So PyTorch is just a package to is a very popular package to create and train deep neural networks of various types, including you saw torch vision and torch audio. Just means they allow for let's say defining working with images and allowing us to work with models called convolutional neural networks and all that. Okay, so that's all fine. So for us, it's not very critical, about all the nitty-gritties about PyTorch, but you can see that there's some imports here, right? So there are like 3 imports which are specific to PyTorch. What these do is help you define the model and also train the model. So first thing is, so first cell, the cell number 2, has nothing to do with PyTorch. Okay, it's a object-oriented programming paradigm here. So it's just a definition of a class. And what does this class do? It's a way to get a batch, a sample of data from your full training data. Okay. Now, why do I need a sample of training data? Why can't I, why do I even need a sample business or a small subset of my full training data? It turns out with neural networks, you generally want to, have access to small samples of the full data. Okay. For example, if you're working with images, you may not be able to work with all the images. Let's say you have, let's say, a million images for your dog versus cat classifier. You may not be able to use all the million images at the same time to train your model. Okay, so you'll have to do some sort of a subsetting, and so this class is just doing that. So for us in the recommendation system, we'll also do something similar where we'll not sample all users at the same time, in some sense, all users and all movies at the same time. We'll pick a small subset of users and movies and do something. Okay, and try to try to do something, and to do that, so I haven't told you what the model is. So at this point, all I'm saying is it just tries to somehow shrink the size of the data. That's what it does. Okay, this loader class. Um, so let's not go into the details of what so instead of like parsing through each sentence here, let me instantiate this class and we'll see what exactly it does. Okay, so I just I press shift enter, so this is gonna this class is now is there. Next is the model class. Yeah, next is the model class. So this is uh, so this is how models are defined in PyTorch. It's a you have an init function. So don't worry about everything else inside the function. Generally, you will have an init function in any class. Okay, it's called a constructor. I think you might have seen this or might have heard of this in object-oriented programming lectures that you might have seen before. And it also has an extra function called forward. Okay, so these are the only 2 functions needed for to define a neural network in in um, in PyTorch, and it also, this class extends what is called the neural network, so nn.module class that's present in this torch. Okay, so torch has something called nn. So nn.module is the base class from which you can create all sorts of models, any models, and any or all of these models generally require an init, generally a constructor, and and always a forward function. So what does the forward function do? It exactly what the name sounds like. It given an input, given whatever be the weights, tell me what the output is. Okay, so if you're building a classifier, then given the input image, let's say you want to say the output should be, let's say, a class. Okay, cat or a dog. For us, it's going to be, for us it's going to be, given a user and a movie, we're going to create a produce an output which is a score, which will say if the score is high, this user may like this movie, and if the score is low, this user may not like this movie. Okay, that's what is happening with this forward function. Okay, so that's what the model is. And there's also a loss function, which just says, hey, whatever your score you predicted, is that score present in the ground truth? So now let me actually use a blank paper basically here so what is the model? So basically we have data. So let me talk about data first. So we have data. In this case, it's a data which is user, movie, or actually item, and then we also have a rating. Okay, you generally don't have a rating most of the time, but this is the data. Okay. So we may have, let's say, 100 users and let's say 1,000 movies. Then basically, you know for a user, for a you won't have data for all pairs of users and movies, but you'll have, for some pairs of users and movies, you'll have a rating. Okay. So that's your training data. Okay, for example, this user 1 may have seen movie 1, 2, and 3, and for that maybe there's rating, some ratings, and that's it. So user 1, we don't have any data point for for movie 4, movie 5, movie 6, and so on. Okay, so this is what the data would look like. So what's the model? The model at the end of the day does the following. Okay, so what does it has to do for any? So it has to recommend for a user a list of movies. Okay, list of movies. Okay, and that's what the code does. But we'll get to the code later. And what is the underlying? So how does this recommend function run? So that's the model case. So that the model is going to say, hey, let me predict a score, which is a function of user. Uh, so something corresponding to the user, and there's going to be user vector. Okay, so this is actually a user. Let's call it parameter vector. All I'm trying to say is all we have given is this data, from which you're going to construct somehow learn this user parameter vector, basically some user vector. And we'll also learn a movie parameter vector somehow. I mean, let's not worry about how we learn it, but there's going to be a vector corresponding to user. There's going to be a vector corresponding to movie, and there's going to be one of these vectors for every user and every movie. Okay. Maybe this vector is of length 4. Okay. So 4-dimensional vector for every user, 4-dimensional vector for every movie. Once you get these two 4-dimensional vectors somehow through model training, then the underlying model says, hey, score has to be user times movie vector. So 4-dimensional vector times 4-dimensional vector, it should be collapsed to one number, plus some, maybe some, like user, let's say in the literature they call it user bias plus, let's say, movie bias. Maybe this user gives high ratings to everything, so user bias just means, hey, offset everything by offset all scores, take into account that this user rates everything highly or something. Or if the movie is already like super popular, then there's also bias like that. So this is, these are the parameters. So okay, so just to recap again, given this data, whatever be the training procedure, at the end of the day is going to learn these parameters. Okay, so user parameter vector, movie parameter vector, some bias parameter. Let me not even call it parameter, plural. Bias parameter, one for user, one for each user. Once you have all these numbers, or basically parameters, then for any user, any pair of user and movie, you can compute a score this way. And then once I compute a score for, let's say I've been given a user. So here in recommend, I've been given a user. So I'll pick up every movie parameter vector, multiply it with the given user's parameter vector, find score for every movie. Okay, so find score for every user movie pair for this given user, and then sort those scores and pick the movies corresponding to the highest scores. Okay, so that's the idea here. That's the model. Okay. So those who've done 572, just to give, so people who've done 572 only, so the rest of the people ignore this, is basically called matrix factorization. It's somewhat of an older model. There are actually many newer innovations these days, but this is the underlying idea is called matrix factorization. Okay. So I don't want to look at the code immediately at this point. Is there any questions about the model? Okay, because actually we don't really care about any specific model in this course. We could have picked up any model, but I just wanted to use this model because we're going to continue using this throughout subsequent sessions. And we actually don't even need to know the nitty-gritties of this model. Okay, this model or this types of models for this course at least.
Professor,
Yeah.
this is Chaitanya. I have a quick question. So is rating part of the data, or we don't have any field called rating in our data?
We do. That's a great question, Chaitanya. So we do have a rating. Yeah, it's an explicit rating.
Yeah, but are we going to use that rating while calculating our score in that like vector parameter?
Yes, exactly. So our loss function, so maybe I didn't define that. So our loss is going to be, hey, you produce a score, whatever score you're producing, I'm going to compare it with the actual rating on the training data. So for training data, I have the ratings. So on the training data, I can see, hey, you produce, so I get to choose parameters, right? I get to choose all these guys. You better choose those guys such that the scores correspond to the ratings at least on the training data. So loss on.
Okay, that is already our existing target variable, which we are going to compare our prediction with.
Yes. So rating is the target. Yeah, exactly.
Okay. Yeah.
Yeah, so just think of it as some sort of a linear model. I mean, you can just think of this instead of, it's not exactly a linear model because there's some product stuff going on, but at the end of the day, if you have a linear model, it would also produce, given some input, produce some score output. You just compare it with some target, right? So this, if you minimize this over parameters, which are all these guys, use a parameter vector, more parameter vector, this guy and this guy, then you'll get the best parameters, hopefully, and that's it. So that's the training of the model. So any questions about this? So what we'll do is take a break for 10 minutes. Let's resume at 7:45. And I'll I'm going a little bit slow because I think I wouldn't say slow. I mean, I may be going a little bit fast. Do give me feedback. But for some of the people who want to really get through material, we are not going to do that because we do want to pause and ponder about many of the things that we're doing here. Okay, it's more worthwhile to spend some more time on these concepts than to keep rushing through many of the material that's at least in the syllabus. Okay, so let me know if I'm too slow, then I can speed up a little bit. But otherwise, we will spend reasonable time on each component. Okay, so we are still getting to the first one. Once we deploy the first model, the other things are going to be easier. Okay, so deploying it in a second way or third way or fourth way becomes easier because it's going to be the same model. Okay, so let's take a break. Let's resume at actually 7:46. Okay, so welcome back. So I want to step back and at least add two more comments before I continue talking about the model. One is that we're going to look at a bunch of Python code. It may be, for some of you, the first time you're seeing this code. I would suggest not worrying too much about it at this immediate point, because those codes essentially are just black boxes for us. The focus of this course is about just deploying such a script on a web server or on the cloud and getting it to serve predictions, right? So whether the script has some complicated model, like a recommendation model that we're seeing, or a simple linear model, or models that you are familiar with, maybe in R, for example, from last time, is not very critical. So since we'll be using this, for example, the model that we see today, right now, we'll be using it over several weeks. Maybe by that time, you'll be a little bit more familiar with the way the script is laid out. But for the first time, since you're seeing it, the expectation is not that you know everything that's going on in the script, but just that, hey, this is a training script, and here's how we could do inference with it. Okay. So let me actually go back to that notebook. I think this is the name of the notebook, on the remote machine. So instead of, so what I decided is not to talk about PyTorch. Let me switch over to the second model, which is easier to at least look at the code first, and then talk about the first model again. Okay. So the second model and the first model, they're exactly the same idea. So, and the idea is exactly written here. Okay, it's matrix factorization. It's just the difference between those two code bases, or those two are just in terms of what packages we're using, underlying packages we're using to implement it. Okay, just like in R, for some of you who have done R, you know that you can implement linear model not just using, let's say, the lm function, but there are other functions which also, so other packages also have ways for you to fit linear models, for example, right? So let's look at this small script just to get a sense of the, so matrix factorization here, it says SVD is the same idea. Okay, so actually SVD is not the right name here. And just for those folks who are not sure what SVD is, SVD stands for singular value decomposition. It is just a specific tool in linear algebra. And matrix factorization, or matrices, have something to do with SVD here in this way of modeling users and therefore making recommendations. And that's why in the name there is this SVD here. Okay. So here's a simple script to train a model. Okay. So simple in the sense that the number of lines is small, only because a lot of complexity has been hidden. For example, you can see there is 3 key imports. One is the algorithm and a dataset object from this library, from this package. Okay, very similar to R. Okay, just always have an analogy with R for folks who have seen R before. And again, we are importing a loss function, RMSE, root mean square error, and we are also importing a way to write this model to disk. Okay, so in this case, it's going to be the disk. It's going to be the local folder or file, sorry, local folder of that remote machine. Okay, so you can see here it says data, load the built-in model. This just is a string. It's specific to that package. It says get the data called movie lens 1 million data set. Okay, so we'll not do 1 million. Actually, let's do 100K. Okay, for simplicity. So these are just some just labels for different models that are the different data sets that are already available in this package. Okay, in this package called surprise. Get the data, get the training data set. Okay. Just we don't even have to know about like, hey, what is meant to build full train set and all that. It's just some training set, because remember everything is being obfuscated, or not obfuscated, but is is happening behind the scenes through this through this package's interface. Okay, so data is an object, is not like your our data frame. It may be slightly different underneath, but we don't have to worry about it. Okay, so there's some train set, and then the algo, the model is instantiated is in this way. So it's just an instance of this svd, let's say svd class. And then very similar to some of the approaches that you might have seen in the past, it's just model dot fit this training data set. Okay, so again, what is the training data set? Essentially, going back here, is going to be something like, hey, this user has seen these 4 movies and they rated it this way. That type of data. Um, and once you do algo.fit, and this may be time consuming depending on how much data set you have. Actually, 1 million may be too much for this small machine. So that's why I changed it to 100K. And then actually we don't even, yeah. So, and then what we're doing is create a test set and already like applying algorithm on this test set to get predictions. So what we're doing is pre-generating, hey, if this user saw movie 1, 2, and 3, what would they have rated for movie 4, 5, 6, 7, all the way to, let's say, 1,000. Okay, that all that is captured by this step, algorithm test. Okay, and then oh, sorry, not okay. So this is training error, and then sorry, training performance, RMSE, and here a test set is generated for everything else that the user has not seen, and for that we are getting the predictions. Okay, this name should not be predictions here. It's like predictions for ratings that we already have, maybe. Okay, for this line, and here is the real predictions for movies that this user did not see. Based on this model that we trained at this line, what would their scores be? And once you have the scores, you can dump both the some sort of the scores for all the movies that this guy, any user, did not see, and the model itself you can dump using the dump function, which is again from that package. So not much is happening in this high level script, right? It's just using the packages, data set object, the model object, some sort of an error metric object, and some sort of a reading and writing to disk object. Sorry, object as in like these functions to run a model. So you can run this. Folks who are running it on Colab, I'm not sure. I mean, so first time you run it, for example, I'm running it on the remote server here. So first time I run it, it says, hey, this data set is not there. Do you want to download it? And I'll say yes. And then it'll download it from this. This is the location from which you can get this small. It's a very small data set, 20 MB in size. So okay, data set is, you got it, and then it's already fit the data. Okay, so it's saying RMSE, which is exactly like, let's go back to this other tab. RMSE is just this, okay, loss compared to what did you predict versus a rating. So if rating is 3 and you predict score 4, then for that observation or that user item pair, you have an error of 1 units, right? So that's what an RMSE is, just an average of that. Okay, so I think now I think as you can see, there's a star or on the left side, which means that this thing is still running. I think when it finishes, we're gonna see a new file in the local folder. Okay. So any questions about this, at least the high level like sequence of steps being that are happening here?
Professor, this is Anupriya.
Hey, yeah.
Can you um, how should I put it? So I got not as in confused, but
Mhm.
can you briefly describe what we just did? So we have to you just went through two recommendation models
Oh,
types of.
no, the first model I paused because it's a little bit longer script. So I just wanted to come to the second script.
Yeah.
The nice thing is that both scripts are essentially doing the same model.
Okay.
So the model is what I wrote here, right? So I can even copy this, paste and paste it on the chat just so that everybody has this on record. Um, so yeah, the model is just this. It's just, somehow maintain a vector for every user, maintain a vector for every movie. And whenever you need to figure out, hey, for this user, does this movie make sense? Multiply those two vectors and maybe extra, user specific, parameter or movie specific parameter, add them all up. And this is the score for that user movie pair. That's the model. And the same model is there for both this cell here, which says, SVD or something. That's the name of the model here, or the pytorch thing that we saw in the first cell, which is a couple of cells above. Cell just means this thing in the green box. Okay.
Yeah.
So it's the same model.
Yeah. It's these are two ways of doing the same thing.
Yeah, it just depends. We're just using two different packages. Just like in R, if you want to do linear modeling, you don't have to just use LM, right? You can use something else.
Yeah. Yeah.
Yeah.
Okay. Okay. Great. Thank you.
So what's this script? What is, this cell? What's doing is hiding a lot of details, right? So model, for example, is just saying SVD and then saying algo.fit. In the first variant, or in above, in two cells above, this algo.fit is like maybe 50 lines of or 20 lines of explicitly saying, hey, how to fit the model, how to fit the model data.
So
So I didn't want to get to that detail right. So what I did was, I got into a more detailed model, and then I thought, let me first talk about a simpler script. A lot of details are hidden here clearly, right? I mean, it's not clear what each of the steps is doing. For example, what is string, what is data build, filtering set, and all that, right? By the end of the day, this is building a model and dumping it to disk. Okay.
So, Professor, do we have to understand it on a high level, or do we have to go through the
No, you
granular
don't have to understand
of
this
the
model at all.
codes?
Okay. You don't have to understand this model at all. So
Okay.
that's why I said so folks who are seeing this a lot of Python code,
Yeah.
don't worry about it. Just know that, we since the focus of the course is deploy some model, it doesn't have to be this recommendation model. It could be some model that you have seen in the past. For example, even an R-based model, right? Or in Python, there's ways to create a very simple linear model. Okay, some toy linear model, right? With you can just randomly generate x comma y pairs and just fit a line, right? That is also fine. We don't need to know the details here. Yeah.
Okay, we are just understanding how this model works on a high level.
Yeah.
High
I'm just talking about the recommendation problem at a high level. So it's the details of this model, these models don't matter.
I got a little lost in the code. This is a huge code.
Yes. And that's why I think I'm repeating for the third, fourth time that don't worry. I mean, for many of you who are new to Python, you may be seeing like a lot of lines of code here. But for us, but the good thing is we kind of repeat the same, we're not going to switch the model. Okay. We're going to keep using the same thing again and again and again every time we deploy. So hopefully by nth time, you'll see hey, it's the same script and same things are happening. But I think by that time also you can get a little bit more maturity in terms of like how the Python code looks like. Okay. But this is a great, I would say, not easy, but at the same time not too complicated code base, or not code base. I would say like a bunch of uh, 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 code to look at. Okay, to get familiar with Python. Yeah. But yeah, I mean, I would say for today's class, I would say this is not important whether you understand these lines or not. Um, yeah. So what this notebook or recommendations or 05 recommendation models section was supposed to do was to say, hey, there are two choices, and just say that both choices have their own pros and cons. Two choices as in uh, the choices being okay, can I use this package surprise, or can I use that general purpose package called torch or pytorch? Okay, so based on whichever one you use, you may have different codes, right? So that's what we are seeing here. But the business problem is just recommendations. Okay, we just need to create recommendations, and let's see. So I'm going to show you. So let me run the next command, next cell as well. This cell is just going to print some recommendations, just so we get a feel for like, hey, what is the input, what is the output. Next command is not doing anything again. It's just what it's going to do is it has a helper function to get recommendations for every user. And in the main part is just saying, hey, get recommendations for every user. And there's an extra metadata file which says what is the name of the movie. And I can just pick some users, let's say some sample of users. Yeah, I mean, I'm just not even sampling. I'm just running a for loop for every user and stopping the for loop after 5 steps, and I'm just printing the recommendations. Okay. For that, you need this movies .data file. I'll just so I'll just copy that movie.data file into this directory. Um, oh, is something running still? Oh, okay, this is still running. Oh, okay, this writing is still running. That's why this machine is underpowered. Okay. Let me run on a different on a local machine just so that we are faster here. Sorry, this is a local machine only because there's a 1-digit change in the URL 8888. But so let me run the first model because it's faster. So I'm just running the cells without reading about them. So let's look at the main text a little bit. For any modeling, you first have to read the data, right? So that's what's happening. Very similar to if you had worked with scikit-learn or in R, you would have to read the data. So it's reading the data here, and then I'm setting some initial hyperparameter style thing for the model, and then I'm instantiating the model, and then explicitly instead of calling model.fit or something lm.fit, here there is an explicit for loop going on which does what is called gradient descent. Okay, for us it's not really critical, the details of the gradient descent and all that. So let me just run this main file, and you can see something's getting printed. In fact, it's saying every iteration what's the loss, and hopefully loss decreases over time. Okay, and this is what you would typically see in many ML. I mean, you can plot these things, right? And you might have seen plotting this and all that before, right? So you can see that for some choice of learning rate, some choice of hyperparameters, the loss is decreasing as a function of some iterative improvement that we are doing with the model. Okay, so here we have trained the model. And then for inference, which is exactly like, hey, given a new user, can you tell me what the prediction is? For that, what I'll do is you need this movies .data file. I don't know if I have it. This is which directory? Okay, actually. Okay, it's in the temp folder. So this is something that I had cloned at the beginning of the session. So okay, so what I did just now is just get that extra file. It's just a metadata file for like, hey, what is the name of the movie? I just wanted that. And after that, I'll just run this inference cell. Okay, all it's doing, again, looking at the main file, it's saying, hey, get some users and just tell me what the predictions are. What did they see and what medical conditions is. Okay, So again, I reiterate for the fourth time or fifth time, don't worry about the number of lines here. For us, it's not so much important to, okay, we don't need to do this. Yeah, now I'm running this this particular cell here. It's just going to print some recommendations. Oops, nope. Okay. Size mismatch. Okay, this should be, sorry, I just changed this to 100K. So keep, it's just a slightly smaller data set. Okay, so once you run the script, by the way, you will not face so many errors, but sorry, let me go back here. Sorry for so much scrolling, but we're just dumping a few things. Okay, this user saw these 10 movies, and he or she might have seen many other movies, but here's a bunch of recommendations. For us, actually, it's not even important whether these recommendations are good or bad. If there's a movie buff in the class, then they can probably post hoc figure out whether this is a good model or not. But this is what that person has seen, and these are some recommendations. Okay, and it looks like all the recommendations. Oh, yeah, it looks like all the recommendations are the same. Maybe the model is not good. Okay. I haven't been. Yeah, there are some changes in the recommendations, I think, or maybe not. Okay, so we have some models. Okay, at the end of the day. Yeah. So again, not to look at Jupyter notebooks, there are a couple of cells. There are a few cells. First heading is about training, first type of model. The second heading is about, it's just the dump of the training thing. Second heading is about, hey, once you have the model, you can read it. You can read it from disk, like you can load the model from like a storage, like a file folder, and make some predictions. Okay, this is inference. Similarly, in the second style, second way of doing it, here's the model script for training a model, and here's the script for reading that model, which is already on the hard disk, and making some predictions like what did the user do, what did they see, and what's my recommendations. Okay, that's what this whole notebook is. It has a lot of lines, but let's move forward. Sorry. So let me go here. So let's switch gears. Actually, I think we went a little bit, first exposure to models. That's what we did for the past few minutes. Now let's step back a bit, because our objective is to actually focus on the ML lifecycle, and in particular, we are interested in model deployment. And our first exercise of getting this remote machine and maybe in setting Jupyter there, or a Python environment there, was so that we could run our Python script there, and therefore the script can through some sort of like through the browser. For example, if I send a feature vector through the browser, it should be able to reply back with, hey, here's the prediction, here's a cat or a dog, right? Or in our case, it should, if I tell my user ID, it should be able to give me the list of recommendations back through, let's say, the browser. Okay, that's what we want to get to. So is the overall goal clear at this point? We are now stepping back and not getting into the details of the model, but the model, again, is what's written in the chat or in the text file that I said. It's called what's called a matrix factorization model. Okay. So let's come back to serving models using web servers. So as as the name implies, model serving, and this is what we'll do for the first 2 or 3 lectures, is about sharing, deploying this model such that other people can query this model for getting predictions. Okay. And there are a couple of ways to do these types of deploying models. One way is which is also quite popular, is where you don't run a model behind a web server. Okay, where what you do is use the model for every test user. There's going to be all these test users who will come, who will visit my movie recommendation page tomorrow, for each of these users, I'm going to pre-compute these list of recommendations on the previous night, and then I'll just dump these list of recommendations as like a some sort of a database lookup where, hey, for this user recommend this list, for the next user recommend this list. Okay, that's a one approach. You just dump predictions, so the model itself is not needed. Once you dump the predictions, it's just you need to have that sort of a database or some sort of a dictionary, if you call, running in the production. You just need access to the dictionary while serving recommendations, okay, while making predictions. The second approach is where when there is a query, for example, somebody asks, hey, give me recommendations for my user ID, then you actually execute the inference step, which is that, hey, then you pick up that model, pass the input, which is the user ID or something like that, and get the list of movie recommendations in real time. Okay, so that's the second way. Both have their own pros and cons, and we'll see actually maybe in the next class. Doing one way or the other way has its has some benefits and some disadvantages. Okay. um, so how do we actually query, let's say we have a model and it's behind a server. How do we query it? What we do is what's called a web request. Okay, and every time we open the browser and we open a website, we are actually making a certain type of a web request. Okay, it could be a what is called a get request, or it could be a post request. So there are different types. But for us, this is the primary way in which other end users, other colleagues in your company or your clients, and that's the way they will typically interact with your model behind, which is deployed on your server. Okay. um, so how to output predictions? We're gonna set up our server as in this remote machine, which we have started earlier. We'll make it so that it serves predictions. Okay, and it will respond to a specific type of a specific type of request called get request. Okay. um, Typically, and we'll just pass a very simple input, just a string, and we'll get some response output, and we'll just try with that first, and then we'll hopefully put in a model in between which takes the input and does something and then produces out. So in the overall goal, because we saw that previous notebook or previous section which had like a lot of text, a lot of code, but it was considering two different models. One was pytorch based one, and one was surprise lift based one. Our objective, at least ideal objective, is to deploy both with one web framework. It's again in Python. It's called the Flask web framework. Similarly, in R, there are some options. I think some of you might have heard of the Shiny package and Shiny based deployment of apps in R. So in Python, there are many choices as well. Flask is something that we'll see in this session today. In the exercises, you'll see some other choices that you can use, like Django or Starlet or others. Okay, and so for the next few minutes, this is what we're going to do. We'll try to get a sense, we'll get a feel for this request library or request package in Python, and we'll also try to deploy a simple hello world type of a app in using this Flask web framework. And you'll see that it's a very nice, transparent, and small enough lightweight thing that you can try first, so that once you get comfortable with that, then you can move on to more complex or more, I guess, sophisticated strategies and softwares to deploy models. Okay. So any questions about up to where we are and where we headed to, and if you're facing any difficulty? Okay, if there are questions, do type it on chat, and I can pick it up from there. So Flask. Okay, so Flask is this it's called a micro web framework. I don't know. Let's see. It was from 2010. Okay, it's about 10, 11 years ago that somebody, I think. It's an open source web framework that was created by this person here, And it's a great framework for beginners, and especially for development style, like if you're not very uh, you know it's a great starting web framework to easily deploy um, uh, apps for non-specialists. And in this case, we are the non-specialists because we know how to build models and diagnose models and work with data, but we are not folks who will who are like the experts in web deployment, right? But so for folks like us, it's a great starting point to serve models. Okay, so for that, I actually have a initial script here, and I'll go over what's happening with the script. Okay, and this is not related to our model deployment. It's an app which is supposed to do weather reporting, but unfortunately that API, api.weather.gov, is off. I found out recently, so we will see that it does something more simpler than weather reporting. Okay, so but let's get to the basics of this. Um, so so the key idea, the key concept in Flask, yeah, the key concept in Flask, let me write it here, is the idea that um, a web URL, a route means like this. Okay, so like for example, let me go to teja.org. So this is a route, teja.org slash, let's say, contact is a route. Okay, so this is what I mean by a route. Okay, so some, like for example, it can also be an IP address, right? I don't know. So we have an IP address for our machine, so it could be IP address slash predict, for example. So uh, so the key idea in Flask and many of these actually web frameworks is that a web URL route is mapped to a function. Okay, so now imagine if we have a function, which a function is what? It takes an input and produces an output, right? So we can think of our model as a function as well. It just takes a test vector, prediction vector, and produces a prediction, like a class label or something, typically, if it's a classification. So these types of web frameworks, what they do is they just let us map, hey, if somebody visits this URL and types this URL, and maybe also gives some information when they visit that URL through like a request, and we'll see that in a second, then let's immediately call this function with that extra stuff that anybody this person sent. And that information typically is like the feature vector, or let's say the user ID or something like that, passes through this function, and this function can just do that inference, okay, which is maybe a lookup, maybe look up in a database of pre-computed predictions, or run the model, like model.predict or something like that on that test input, and then return the output. Okay, return it back to the browser, or return it back to wherever the request came from. So um, let me let's see where I can show this. What I'll do is I'll show it on local machine, because actually we can do it on remote machine directly. Okay, so I think some script here is still running. I think, okay, let's not worry about this. Leave. So this is our remote machine, okay, because it's 8889. And if I refresh this, looks like nothing is running. Um, yeah, so let's click Flask app. I don't know if that machine has, okay, inactivity issues. The machine is definitely running, right? It is running. We just lost connection to it. Okay, I will, what I'll do is run it locally. Anyway, it's So this is a local machine. So let me just open, I actually have this right somewhere. Um, okay, let me close this. Okay, so let me run Flask app directly. Actually, simplest thing to do is to copy this text. Okay, and somehow I lost connection to the remote machine, although it's running. So I'll just create a new text file. Okay, this is on the local machine. Paste it here, and let's call it class example.py. Okay, and save it. So where have I saved it? Just to see where it is, I can just see it is here. Oops, I think it's in. Yeah, it's in.
I think it's in chapter 1.
Yeah, it is in chapter 1. It says in the URL. Thank you for that. I just saw that. Okay, so it's in chapter 1. I just wanted to go into chapter 1. Chapter 1. And I just wanted to run it here just so that it doesn't cloud the Jupyter Notebook environment. So generally, the way you run a web server, and this is the simplest instance of web server, is just run by Python flask example.py. Okay, so I don't know if I'm running anything else at that location. Oops. Yeah, that address is already in use. Okay, so I can just change the address, comma port is equal to 5001. Okay, or I don't know, do you like 594? Let's say 594. And sorry, not this one. So I'm just running, I just created that file. I just copied it from that cell, and I created that file, changed the port because I think something is already running. But what happened? Looks like I have several Jupyter instances running. Okay, let's see. So I have an issue. Oh, port 594 actually is a protected port, so I should have tried something else. So let me go back here. I apologize for that. So let's see, something like 13,000, let's say. This should ideally work. Let's go back here. Okay, so it's running. So I just ran it on the local machine because I somehow this really failed. So let's close these things which are trying to. So I have this. So again, just to step back, I apologize for the issues there. So we copied this cell from the MLOps Flask apps page, right? And all I did in terms of change was add a port here. And you don't have to do this. I just had to do this because I might have been using that port earlier. Um, I copied it in a file, changed the port, and then I went to command line and I said Python flask.py, and now the web server is running. Okay, so now let's go back and parse. What is this few lines of code, this 30 odd lines of code are doing. Okay, there's a bunch of imports. Okay, related to Flask itself. So what this app is supposed to do is, so it's supposed to uh, respond to a request as some query, let's say a third party, or for example you or me. If we ask for the weather in, let's say, Chicago, it should ideally tell us the weather in Chicago. Okay, so that's what the app is supposed to do. Before I even parse this bunch of text here, what I want to point out is that you can see a couple of lines here. The most important lines are 10 and 11. So here it's saying, hey, here's a route. If somebody visits, let's say, localhost 5001 slash, then I should immediately trigger, and hopefully they give us some information slash, let's say some information like, hey, get me weather for Chicago or something. Then I should immediately trigger this function, weather. Okay, and that function will say, hey, you might have passed this information, like which place, if there's a message with a location, which says, hey, give me weather for Chicago, then I'll do some extra, legwork in trying to query this extra API from weather.gov to get the weather of Chicago. Okay? That's what it's trying to do. Okay? And there's some extra glue code, or if that, if I'm not able to get the weather, let me just, forget about it. And there's some extra package which converts from the string Chicago to actually Chicago, Illinois, and get me also the latitude, longitude, and stuff like that. Okay, so that's what's happening in this piece of code. Let's see how it functions first, and then come back to this. So local host, I think 13,004. Was it? Yeah, 13,004 was the IP address, and you can see I did not give any information, so it says, hey, there's no other information. So here's a get request. I can put a question mark, and here I can pass information, and even you can pass the full test feature vector. Okay, so for example, your user profile. So let's say here, and we'll go back to the code in a minute. So MSG, this is the message, it's the key, and the value is going to be, let's say, Chicago. Okay, so if I send this and press enter, ideally what the code has to do, let's come closer to this. Ideally what the code should do is say, so when I hit enter over there for this, right, with this string, the code is going to pick up first, is immediately going to trigger this function, and the function says, creates a dictionary. Okay, it's just like, I don't know what's the equivalent in R. I don't recall at the top of my head, but it creates a key value pair with success being false. And then first geocodes. Geocoding is nothing but a way to figure out from a rough address, like a rough geolocation, what that correct geolocation is. Okay, so I instantiate some object here, and then hopefully there are some parameters. If there are parameters, I'm just saying that let's just, I'm just redefining what the parameters are. Okay, I'm just checking, hey, did this person pass MSG, which let's say stands for message. Okay, if they pass the message, then let me first geocode that location. Let's say it's Chicago, and now I have I'm going to add that information to my dictionary or key value pair that I'm maintaining. So I'm adding, in location, I'm adding what the actual address is that we decoded. What is this location's latitude? What is this location's longitude? What is this location's altitude? There are many other things that I could write here. Okay, once I have for example, latitude and longitude, I am in turn making a request, and this is what I said, programmatically making a query to any service. You can do requests.get of any URL. Generally it should be service, like our model prediction services will also, we did something similar, right? We had a URL with some input. So this code is also doing the same thing. It's just like sitting in between the user and the weather.gov and saying, user sends a request, it's again passing the request back to weather.gov with the right lat long values. And apparently, I think this API requires 2 queries. First you get the lat long to get into the right box, and in that box you get the weather forecast. Okay, and whatever they respond is saved in the response. And because now we actually retrieve weather, it's just saved as success. But if you go here, you can see that it's not really success because weather.gov's API is not working now this semester. And so what we did is decoding. Okay, this is, I only passed in Chicago. It gave me Chicago, Illinois, United States, and it's lat long and altitude. Okay, so I can give other things. Um, I don't know. What's the location? Let's say Springfield. I don't know. It's a okay. It actually found the right place, but okay. So none of the queries we're getting the weather information because the weather thing is not working. Okay. So that's how a Flask or any web server would look like. The objective of this part was to just show, hey, the web framework, at least these web frameworks, what they do is just map the route. Okay, instead of slash, if I said slash predict, okay, map the route to a function. And as long as the function can do the prediction, and this function is just pure Python function. It doesn't have to talk about weather and all that. It can directly, make a prediction for the input. Okay, so if I, for example, if I make this change and rerun, and if I go here and instead of calling here, I can call at the predict route, and again I got the prediction, right? Yeah, I'm just getting the prediction here. It's not really a prediction, it's just responding back with the geocoded information about that string that I passed. So that's the minimum requirement, and I think next class I will change the input to the model. Okay, to one of the models, and it doesn't have to be these models. We can pick any model, but I just picked the recommendation system models. Okay. So sorry for the hiccups in the second part of this lecture. If there are any questions, I'm going to be here, so we can go deep dive into any of the parts that were not clear for folks who want to stay on and ask questions. Thank you for your attention. I'll see you guys next week.